We've had some practice acting like planetary geologists working on Mercury and the Moon, but now we're really going to be put to the test looking at Mars. What I want to do is show you several different types of features that can be found on Mars, which illustrate that Mars is a more active, or at least has been a more active place than the Moon and Mercury. And then I'm going to ask you, your assignment for this lesson is going to be to find an example of each of these features and take a screenshot and submit it. So I'm going to show you an example. My hope is you find another example somewhere on the surface of Mars, and I'm going to try to give you some hints as to where you can find these sorts of things. So the first thing I'd like you to try to find is what I'll call a preserved crater. Preserved crater would be any crater that looks essentially like the crater just happened. And we're going to compare that against an eroded crater. So let's take a look. Now, I can see a few preserved craters just from looking at the whole surface of the planet. And by preserved crater, I mean one that has a very clear, so I'm looking up here, I see a couple examples. A preserved crater would be one that has a very clear rim to it, very sharp, crisp circle that it makes. There hasn't been any erosion and nothing else has hit it, it looks like. And I want to look at it in a few different ways here, right? We can look at the elevation. I can turn on the visible light, which in some parts of Mars may be more clear or sharper images, and I can look in the infrared light, which will often be our sharpest images. You can see I can see a piece of it there, but these dark gray bands are places where they have not yet taken pictures at this wavelength of light. So I can find another example, though, nearby, I'm sure, of a preserved crater. This looks like a good example, right? So it's got sharp, clear boundaries. Maybe it's eroded a little bit. So the idea of preserved crater is the sharpest, clearest crater I can find. All right. Now the second example would be an eroded crater, and I don't have to look far to find an example like that. An eroded crater would be one where it looks more like the wind has blown or something's happened to kind of cause that crater to kind of disappear over time. Let's keep it in the infrared. Let me just zoom back out again. There are some better and worse places to look for craters. So if I'm looking for eroded craters, I'm probably going to look down here where it looks like it's a much older surface. So I'll zoom in. How about over here? All right, an eroded crater. This looks like a good one right here. Right, this crater here is clearly very old, and the way what's worth pointing out here about Mars is that these eroded craters, like here's another example right here, these eroded craters illustrate that there's been wind and possibly water flow on the surface of Mars. So it's telling us there's more happening. There must be an atmosphere that can have this sort of wind blowing. Okay, so those are the two types of craters I'd like you to find. I'd also like you to find some collapsed lava tubes. Okay, so there's clear evidence on Mars that in the past there's been volcanic activity. We can see that with these really tall volcanoes that we can see scattered around the planet. Well, volcanoes have underground tubes that carry lava around, and sometimes these tubes, once the lava is no longer in there and it's all cooled, they collapse. And what you'd see is a long kind of straight line that looks kind of like it's collapsed down into the ground. So to find a collapsed lava tube, I'm going to look near a volcano. If I do that, even just with my elevation here, I see some of these straight lines. I think many of these are examples of collapsed lava tubes. They'd be narrow, right? So I'm not looking at like these bigger things, which look more like kind of channels or canyons. I'm looking at something like this, right? And I look in the visible, and it looks like it's been a little collapsed thing. And again, the infrared is going to be my best picture, except for these streaks in there. But I can zoom around and see these are all examples of collapsed lava tubes, where they've just kind of sunken into the ground where lava was once flowing. Okay, so you can find a lot of those around volcanoes. The next thing I'd like us to find is a landslide. All right, so and all of this is just pointing to the fact that we have an active atmosphere on Mars, but also that perhaps there's something liquid underneath the surface, or at least icy, sloshy, something, because things are flowing even on the surface itself. We can see that with landslides. Now, we're going to find a landslide most likely by canyon walls, and there's a huge canyon, Valles Marineris, on Mars. So I'm going to look near that canyon and zoom in and try to find something like a landslide. So what would a landslide look like? I'm going to switch to the infrared light here. A landslide would look like where there once was a steep wall, but you can see like material has kind of like fallen around it. So this is a decent example. Here's a steep wall, and you can see there's kind of like this little edge to the material that looks like it has fallen down from the edge of the canyon. Let me show you one more example. So I'm just scanning around, looking at the edges of the canyon walls. Oh, this is a good one. Okay, so I don't want to steal all the good ones here, but there's a lot to find. So here's a canyon wall, and you can see all this material has fallen and slid down from the canyon wall like a huge landslide. All right, so it's telling us something, that perhaps this is not the material of the surface of Mars itself could flow and collapse down and slide. So it's not like it's all just solid rock like that. All right, so there's a landslide. Now, a streamlined island is the next thing I'd like you to find. Now, this is where we start to see really interesting evidence that water has at some point flowed on the surface of Mars. And if it was, you can see the top of Mars is much lower than the bottom of Mars. Like the northern hemisphere is much lower. So flow would presumably happen from the southern hemisphere to the northern hemisphere. And you can kind of see already, even at a global scale here, what looks kind of like flow of some sort of liquid. And evidence suggests that was, in the past, water. Now I can see, if I see a lot of them here, if I just zoom in on one of these little islands here that's kind of sticking up, I can kind of see, see here's some really good examples. I can see what I would call a streamlined shape to the island, which suggests that water, and a lot of it, was flowing past this at some point in the past that gave it sort of this teardrop shape. So I'd like you to find another example of something like that, a teardrop shape, a streamlined island shape. Okay, and the last thing I'm going to ask you to find is wind streaks. Okay, so really direct evidence that wind is blowing on the surface. And to find this, I think the visible part of the spectrum is the most helpful, because there's these dark parts scattered around on Mars. And if you look at some of those dark spots, I think you kind of see, maybe not as much there, it's kind of smeared out, which we'd say is because of the wind. I think we can find some more better examples of that. Let me find a really big dark area. Let me zoom out a little more. Yeah, here's some nice dark spots. Let me check this out. And when I go and check out these darker areas, which means that sort of they're darker because wind has sort of swept the dust off the surface, and so you can kind of see the rocky part beneath. And you can see here's some really good evidence. Like I'd maybe take a screen capture of this area right here where wind, or maybe right here where wind is clearly blowing, and you kind of almost like see the shadow of these little hills because the wind has blown the material around it. Alright, so that's a lot of things to look at, but hopefully you can revisit this video for the hints on where to find these different kinds of features. I'll tell you, if you can find all 6 of these things, you're definitely on the path to being a Mars planetary geologist.